Good evening and welcome to this video for the 2021 Level 3 Differentiation paper. So for this paper, NZQA has not released the marking schedule, so I do not know the individual grades that each question is worth. And there is a possibility that I do make some mistakes, so I'm just going to bring that out as a disclaimer, so there is that possibility. But I will try my best to go through this paper as best as I can. So for question 1, we are asked to differentiate y equals to e to the power 3x sine 2x. So for this question, we're just going to use the product rule. So dy over dx, and if we differentiate e to the power 3x, we'll get 3 times e to the power 3x multiplied by sine 2x. The second part remains the same. And we're going to add it to the differentiation of sine 2x, and that's 2 cos of 2x multiplied by the first part, which was e to the power of 3x. And for this question, I would say this is just a simple achieved double question. Question B, the graph below shows the function y equals to f of x. So for the function above, find the values of x that meet the following conditions. So we have f dash of x is 0, so that's the gradient equals to 0. So this will be the point where we see the flat line, so the rate of change is 0. So there's one point at x equals to 4, the bottom of this parabola. And for x is less than 2, we see that the gradient is 0, it's a straight line. So we're going to say that the values of x that meet the conditions for the gradient is 0 would be x is less than 2 and x is equal to 4. Number 2 is f of x is concave upwards. So concave upwards, that means that the second derivative is greater than 0. So in this case, we're going to be looking for the part where I like to remember concave upwards as like it looks like a happy face, and when it's concave downwards, it looks like a sad face. So in this case, we're going to look for in between x equals to 3 and x equals to 6, we do see that it is concave upwards. So we're going to say x is less than 6, but x is greater than 3. What is the value of f of x as we approach 7? So in this case, if we look at the graph, if we look from the left-hand side and the right-hand side, they both approach to the same point, which is 3. So that will be our limit for this question. So that will be 3. This should be, okay, so usually NZQA does this as a merit question, and if you get, for example, like one part out of 2 parts, you might get an achieved grade for this question. Alright, a curve has the equation y equals to 2x plus 3 times e to the power of x squared. Find the x coordinates of any stationary point on the curve. So in this case, we're going to expand the brackets out so we can get our 2 separate terms. So we have y, wrong color. So we'll say that y is equal to 2x times e to the power of x squared plus 3e to the power of x squared. So for this first term here, we're going to use the product rule to differentiate, and for the second part, we can just differentiate as normal. So dy over dx equals to 2 times of e to the power of x squared plus 4x squared times e to the power of x squared plus the derivative of 3e to the power of x squared, which is just plus 6x e to the power of x squared. Alright, so we need to find the stationary points on the curve. So stationary points, we know that means that dy over dx equals to 0. So in this case, we can say dy over dx. We can factor out e to the power of x squared since all of the terms have e to the power of x squared in it. So we can say e to the power of x squared bracket 2 plus 4x squared plus 6x. And we know that e to the power of anything is going to be greater than 0. So we can just ignore this part. So we say dy over dx equals to 0. So therefore, 4x squared plus 6x plus 2 equals to 0. And we can just, at this rate, we can just use the quadratic function on our calculator to find the x values. And we should get that x equals to negative 1. X equals to negative 1 and x equals to negative 1/2. That will be our final answer. And this should, again, just be a merit level question with an achieved grade coming with after you define the correct derivative. So correct derivative is usually just an achieved level grade. If you can get both your final answers, that's usually just a merit level grade. Question D. A curve is defined parametrically by the equations x equals to t squared plus 3t and y equals to t squared times ln of 2t minus 3. And this is valid for t is greater than 3 over 2, since ln of a number needs to be positive in order for it to give a real output. So to find the derivative, we need to find both dx and dt and dy and over dt. So if we differentiate x with respect to t, we'll get dx over dt equals to 2t plus 3. And we can use the product rule to differentiate t squared ln 2t minus 3. So dy over dt equals to 2t ln of 2t minus 3. And add it on to the derivative of ln 2t minus 3, that's just 2 times of t squared over 2t minus 3. So if we simplify this a little bit, we'll get dy over dt equals to 2t ln of 2t minus 3 plus 2t squared over 2t minus 3. To find dy over dx, we say that dy over dx is equal to dy over dt times dt over dx. So we see in this case we get equals to dy over dx. So we have dx over dt, so to get dt over dx we just need to find the inverse. So in this case we say that dt over dx equals to 1 over 2t plus 3. And all we need to do to find dy over dx is just to multiply dt over dx and dy over dt. So in this case we'll have dy over dx equals to 2t ln of 2t minus 3 plus 2t squared over 2t minus 3 over 2t plus 3. Alright, so now we need to find the t value in order to find the gradient at the point 10, 0. So at the point we have x equals to 10, y equals to 0. So we can say that to find the t value we can plug in x equals to 10. So we have 10 equals to t squared plus 3t. And now we can say t squared plus 3t minus 10 equals to 0. And that will give us t equals to 2 and t equals to negative 5. Alright, so since t is greater than 3 over 2, we're going to eliminate this t equals to negative 5 value. So we're just going to use t equals to 2. So therefore we can say dy over dx is equal to 2 times 2, it's ln of 2 times 2 is 4 minus 3 is 1, plus 2t squared is 2 times 4 over 2 times 2 minus 3, which is 1, all over 2t plus 3, which is 7. So dy over dx equals to 2 times 2 ln of 1. Ln of 1 is actually 0, so we can just ignore that term. And we have 2 times 4, which is 8 over 1 is still 8. So this will give us 8 over 7. Positive 8 over 7 should be our final answer for this question. And this should be a merit level question. To get an achieved, usually this is just a correct dy over dx is usually enough to get you the achieved grade for this question. Alright, so question E. A cone has a height of 3 meters and a radius of 1.5 meters. A cylinder is inscribed into the cone as shown in the diagram below. The base of the cylinder has the same center as the base of the cone, so prove that the maximum volume of the cylinder is pi meters cubed. Alright, for this question, we can just start off with the basics by writing down the expression for the volume of the cylinder, which is volume equals to pi r squared h, where r will be the radius of the cylinder and the h will be the height of the cylinder. Alright, so as you can see here, the height of the cone is 3 meters and the radius of the cone is 1.5 meters. And if we keep that same ratio, for example, if we draw a right angle triangle like this, we call this angle theta. So we can say that tan theta is equal to 1.5 over 3. So tan theta is equal to 1/2. And by congruency, we know this angle is also theta, right? This angle there. This angle is also theta. And we can call this, we can draw another right angle triangle. We're going to call this side x, and we can call this side h, and that will be the height of the cylinder. And similarly, we can say that tan theta equals to x over h. So by that logic, since theta is the same, we can say that x over h equals to 1/2. And therefore, we can say 2x equals to h. As you can see here, we can call the radius of the cone, we can call the big radius is just 1.5 here. And we know that the small radius r is equal to 1.5 minus this x value here. So we say r is equal to 1.5 minus x. And if we rearrange in terms of x in this expression, we can say x equals to h over 2. Therefore, we can now write the expression for the volume of the cylinder. So we can say that volume equals to pi. R, we now know, is 1.5 minus h over 2 squared times of h. So now we just need to simplify and differentiate with respect to h, make equal to 0, and then we can find the h value and therefore the maximum volume. So we say that v equals to pi times of h squared over 4 minus 1.5 h plus 2.25 all multiplied by h. And if we keep multiplying through, we'll see it's h cubed over 4 minus 1.5 h squared plus 2.25 h. Alright, so now we can find dv over dh, and that's equal. We can just leave the pi outside since it's a constant. So we can just say pi, and then we differentiate everything inside with respect to h. So h cubed becomes 3h squared over 4. Negative 1.5h squared becomes negative 3h, and we get plus 2.25. Alright, so we know dv over dh equals to 0, and that's for the maximum volume. So since dv over dh is 0, so we can just ignore the pi here, and we just have 3h squared over 4 minus 3h plus 2.25 equals to 0. And at this rate, once you get the quadratic, I'll just use the calculator since there's no requirement to show the quadratic form. You can use quadratic formula, so negative b plus or minus square root of b squared minus 4ac over 2a. But in this case, you can just go straight to your calculator, and you will get that h equals to 3 and h equals to 1. Alright, so now what we should be doing is, since we want the maximum volume, and the question, so usually level 3 questions, they ask you do not have to show that it's the maximum volume, but in this case, we don't see that statement, so that means we should probably show that this, which h value is the maximum value. We can do that by simply finding the second derivative. So we can say that d squared v over the second derivative is equal to pi times of 6h over 4 minus 3. Let's try h equals to 3 first. So this will be equal to pi times of 6 times 3 over 4 minus 3. And that is equal to pi times of 18 over 4 minus 3. And that is equal to 1.5 pi. So this is greater than 0. So by the second derivative test, this must be a minimum. Okay, must be a minimum. Okay. And if we try h equals to 1, so d squared v second derivative is equal to pi times of 6 over 4 minus 3. And that's equal to negative 1.5 pi. So this is less than 0, so by second derivative test, this is the maximum. So h equals to 1 is what we want here. H equals to 1. And now all we need to do is substitute h equals to 1 back into our volume formula. So v equals to pi times of 1.5 minus h over 2, which is 0.5, squared times of h, which is 1. And in this case, we'll see that v equals to pi times of 1 squared times of 1, and that is just pi centimeters cubed. And that is as required for the question, that's pi meters cubed. And that's what we have here. And this will be an excellence level question for sure. This is excellence to get all the way up to the pi centimeters cubed. To get a merit grade is usually just being able to find the two h values. I think that should be enough to get you a merit grade. And achieve grade, that's a tricky one. I guess if you can find the correct expression for volume in terms of h explicitly, I guess that could be enough for an achieved. But do not quote me on this. I'm not 100% sure on the grading. There's specific parts you need to get a merit or achieve grade. Alright, let's move on to question 2 now. Differentiate f of x equals to 1 minus x squared to the power of 5. So in this case, we're just going to use our simple chain rule. So f dash of x equals to 5 times of 1 minus x squared. Bring the power down by 1, so now it's to the power of 4, times the derivative of the inner function, which in this case is just negative 2x. And you don't need to simplify your answer, but if we were to simplify, we just bring the x to the front, and that would be our final answer. And this will just be in an achieved level question. A curve has the equation y equals to x squared over x plus 1. Find the coordinates of the stationary points on the curve. So once again, stationary points, that's dy over dx equals to 0. So in this case, we have dy over dx is equal to, so we're going to use the quotient rule in this case. So the derivative of the numerator is 2x, multiplied by the denominator, which is x plus 1, minus the derivative of the denominator, which is just 1, times the numerator, which is x squared, all over the denominator squared. Since dy over dx is 0, we can just say that dy over dx is 0. So therefore, 2x times x plus 1 minus x squared equals to 0. So 2x squared plus 2x minus x squared equals to 0. So therefore, x squared plus 2x equals to 0. And if we factor out our x here, we'll get x times of x plus 2 equals to 0. And by definition, we can see that x equals to 0 and x equals to negative 2. And just to check these points are valid, so x equals to 0, that gives a real result, and x equals to negative 2, that also gives a real result. So just to check, for example, let's say we were to get x equals to negative 1. So we see that x cannot be negative 1 since if we put x equals to negative 1 into the equation, we'll have the denominator equals to 0, and you cannot actually divide by 0. So it's very important for things that have a denominator that you always check that your final answer will provide you a real answer. So in this case, we see that both x equals to 0 and x equals to negative 2, that both is valid in the domain of this y equals x squared over x plus 1. So they're both valid. And we can say should be just another simple, straightforward, achieved question. Alright, a curve has the equation y equals to x squared plus 3x plus 2 times cos of 3x. Find the equation of the normal to the curve at the point where the curve crosses the y-axis. Alright, so equation of the normal, so that's perpendicular to the tangent line. And we know that the gradient of the tangent line times the gradient of the normal line, that is equal to negative 1. But first of all, in order to find the gradient function, we need to differentiate the function. So we're going to expand this bracket. So we say y equals to x squared cos of 3x plus 3x cos of 3x plus 2 cos of 3x. Alright, so now we're just going to use the product rule to differentiate. So we say y dy over dx equals to 2x cos of 3x. Derivative of cos is negative sign. So we say negative 3 x squared sine of 3x plus 3 cos of 3x minus 9x sine of 3x minus 6 sine of 3x. So that's our gradient function. That's a pretty long one. And we need to find the equation of the normal where the curve crosses the y-axis. So if we cross the y-axis, we do know that when the curve crosses the y-axis, the x value is equal to 0. So we can just plug in x equals to 0 into this gradient function. So 2 times of 0 times cos of 0 minus 3 times of 0 squared times sine of 0 plus 3 cos of 0 minus 9 times of 0 times sine of 0 minus 6 sine of 0. Alright, so sine of 0 is 0, so that's 0. Sine of 0 is 0. 0 times anything is 0, and that's all just going to be 0. Cos of 0 is 1, so cos of 0 is 1, so we do have this is equal to 3. And we know that 3, so that's the gradient of the tangent. Okay, so this here is the gradient of the tangent. Oh, sorry, it's very messy. Okay, gradient of the tangent. And to find the equation of the normal, we need to say that the tangent gradient multiplied by the normal gradient is negative 1. So we say 3 times of gradient of the normal is equal to negative 1. So gradient of the normal is equal to negative 1 over 3. And now we can just write our standard equation for the line, which is y equals to mx plus c. In this case, m is negative 1 over 3 plus c. So we need to find the equation of normal when the curve crosses the y-axis. So that's when x equals to 0. So we're going to find the y value when x equals to 0 by substituting x equals to 0 into the original equation for the curve. So y of 0 is equal to 0 squared plus 0 plus 2 times of cos of 0. And that's going to give us 0 plus 0 is 0, plus 2 is 2, and then cos of 0 is 1, so that's just 2. So we have 2 is equal to negative 1 over 3 times x, which is at this point is 0, plus c. And therefore c is equal to 2. So therefore y equals to negative 1/3 of x plus 2. And that's our final answer for this question. This should just be another merit level question with an achieved level grade coming when you can find the correct gradient of the tangent dy over dx. So up to here, that should be enough for a achieved. Okay, so the volume of the spherical balloon is increasing at a constant rate of 60 centimeters cubed per second. Find the rate of increase when the radius find the rate of increase of the radius when the radius is 15 centimeters. Alright, so we're given, so write down what we're given here. So we're given dv over dt. dv over dt equals to positive 60 centimeters cubed per second. And we know that the volume of a sphere is v equals to 4 over 3 pi r cubed. And we're going to be writing down what we need to find. So what we need to find is dr over dt. So dr over dt is something we need to find out. So dr over dt, we can say it's equal to dv over dt times of. So we want to get rid of the dv, so we place dv on the denominator here. And we want to introduce dr, so we place dr on the top here. So we need to find dr over dv. And good thing here we have our equation for the volume of a sphere. So we can easily find dv over dr. So we can say that dv over dr is equal to 4 times 3 over 3 pi r squared. And that's equal to 4 pi r squared. So therefore dr over dv will be the inverse, which is just 1 over 4 pi r squared. So we can say that dr over dt is equal to dv over dt is 60 times of 1 over 4 pi r squared, and that's equal to 60 over 4 pi r squared. And now we can just substitute that radius equals to 15 centimeters in order to find our dr over dt. So dr over dt is equal to 60 over 4 pi times 15 squared. That's equal to 60 over 900 pi. 15 squared. And that should give us a rate of change of around 0.02122 centimeters per second. Alright, so that's our final answer for this question, and this should just be a merit level question. Very, very typical merit question. And to get an achieved, we should be looking at a correct expression for dr over dt. So around here will be a merit. Not merit, an achieved. Alright, so the graph below shows the curve y equals the square root of 2x minus 4 and the tangent of a curve at point P. The tangent passes through the point -2, 1. So find the coordinates of P. So this question is a bit of a tricky question, but if we follow the steps, we have enough information to find out eventually what point P is. So the first thing we've got to do, since we're working with the tangent, is we obviously need to find the we need to find the derivative of the curve. So y equals to 2x minus 4 to the power of 1/2. Therefore, dy over dx by the chain rule is equal to 1/2 times 2x minus 4 to the power of -1/2 times 2. So therefore, dy over dx is equal to 2 times 1/2 is 1, so this will just be 1 over square root of 2x minus 4. Alright, so at this point P, we'll call point P, we'll say it's x1, y1. So this is point P, okay? We'll just call it x1 and y1. So the gradient at point P, we can therefore say is dy over dx equals to 1 over square root of 2x1 minus 4. So we can say that y equals to mx plus c, which is the equation of a straight line. And by similarly to what we did for one of the previous questions, we can substitute our gradient into this equation. So this is equal to m, So y equals to x times of 1 over 2x1 minus 4 plus c. We know the curve will pass through the point x1 and y1, and where y1 is equal to square root of 2x minus 4. So therefore we can say that y1 is equal to square root of 2x1 minus 4. And we can use this information to find the c value. So we can say that square root of 2x1 minus 4 is equal to x1, since at this point x is this point P, so we're saying that x equals to x1 over square root of 2x1 minus 4 plus c. So therefore c equals to square root of 2x1 minus 4 minus x1 over square root of 2x1 minus 4. Alright, so that's all good. So now we have y equals to x over square root of 2x1 minus 4 plus square root of 2x1 minus 4 minus x1 over square root of 2x1 minus 4. We know that the line passes through the point negative 2, 1, and we can substitute this in to find the value of x1. So we can say that our y is 1 and x is negative 2. X is negative 2 over square root of 2x1 minus 4 plus square root of 2x1 minus 4 minus x1 over square root of 2x1 minus 4. Alright, so for this one, we can just multiply everything by square root of, so multiply through by square root of 2x1 minus 4. So in this case, we'll have square root of 2x1 minus 4. That equals to negative 2 plus 2x1 minus 4 minus x1. And now it's just some simple algebra. So we have 2x1 minus 4 equals to 2x1 minus x1 is just x1 minus 6. And we square both sides. So we have 2x1 minus 4 equals to x1 squared minus 12x1 plus 36. Alrighty, so now we want to make the left-hand side equal to 0. So we say that 0 equals to x1 squared minus 14x1 plus 40. And 0 equals to x1 minus 10 and x1 minus 4. So we can say that x1 equals to 4 and x1 equals to 10. However, there's only one of these points that's valid, since once you square the left-hand side, you create an invalid solution, since square root of something can be negative. So we're going to plug these 2 points in to see which one is valid. So originally we had square root of 2x1 minus 4 equals to x1 minus 6. So let's try x1 equals to 4. So square root of 4 times 2 minus 4 equals to negative 2. So in this case, we're going to take the principal square root. So this is the positive value of the square root. So therefore, 2 is not equal to negative 2. So x1 is not a valid solution. So let's try x1 equals to 10. If we try x1 equals to 10, we'll get 20 minus 4 equals to 4. So therefore, square root of 16 equals to 4, and that is correct. So therefore, we say that x1 equals to 10, that is the correct solution. And if we come back to the very start, it's asking us for the point P. So since we know that the x value is 10, we just need to plug in 10 into the equation to find y1. So y of 10 is equal to square root of 20 minus 4, the square root of 16, and that's 4. So therefore, point P is the point 10, 4. Alright, and that's our final answer for this question. Okay, a very tricky question, I must admit, but it is doable if with the knowledge you have at level 3. So that's 10-4. That's an excellence level grade there for sure. To get a merit grade, if you can get both of these x1 values, and then that should be a merit grade. And to get an achieved grade, if you can I guess if you could get up to this step where you have the gradient, the tangent line, and with respect to x1, I guess that could be enough for an achieved grade. Alrighty, question 3. Differentiate y equals to cotangent x over x squared plus 1. So in this case, we can just easily use the quotient rule. So dy over dx. Derivative of cot is negative cosec squared multiplied by x squared plus 1 minus 2x times cot x over x squared plus 1 squared. And we do not need to simplify our answer, so we can just leave our answer like this, and that is an achieved question there. The graph of the function y equals to 4 root x minus 2 plus, y equals to 4 root x minus x plus 2, and x is greater than 0, has a stationary point at Q. So find coordinates of Q. So once again, this is another I think this is the third time they asked the question with the stationary point. So dy over dx equals to 0 once again. Okay. So So we can say that y equals to 4 times x to the power 1/2 minus x plus 2. So therefore dy over dx equals to 2 times x to the power negative 1/2 minus 1. And therefore dy over dx equals to 2 over root x minus 1. We know that dy over dx is 0, so therefore 1 equals to 2 over root x. Root x is therefore equal to 2. Therefore, x equals to 2 squared, which is 4. So we need to find the coordinates of point Q. So then we just substitute x equals to 4 back into our equation for y. So y of 4 equals to 4 root 4 minus 4 plus 2. And that's equal to 4 times 2 minus 4 plus 2. And that's equal to 6. And that's our final answer. So 4, 6 is the point. And that should be another achieved level question. For what values of x is y equals to x over x squared plus 4 increasing? So increasing is, we know increasing means that dy over dx is greater than 0. So to find dy over dx, we're going to use the quotient rule again. So dy over dx equals to, derivative of x is 1, so 1 times of x squared plus 4 minus 2x times of x all over x squared plus 4 to the power of 2. And we want dy over dx is greater than 0, so this is greater than 0. So therefore we can say x squared plus 4 minus 2x squared is greater than 0. Therefore x squared, negative x squared plus 4 is greater than 0. So therefore x squared is less than 4. Actually, we can write this one instead as we can write it as x squared minus 4 is less than 0. And we say that we can say this is x plus 2 and x minus 2 is less than 0. And in this case, we can draw what this parabola might look like. This parabola will look something like this. We have 2 and 2. And as you can see, it is below the x-axis in between negative 2 and 2. So therefore, we can say that between x and negative 2, f of y is increasing. Alright, and that's our final answer for this question. And this should just be a merit level question for the correct bound. If you can get up to, I guess, around this step here, that should be an achieved. A curve has the equation y equals to 4x plus k over 4x minus k, and x is not k over 4. The point P lies on the curve and has an x-coordinate of 3. The gradient of the tangent of a curve at P is negative 8 over 27. Find the possible values of k. Alright, so in this case, we're going to find the derivative. And we're going to substitute x equals to 3. And the gradient equals to negative 8 over 27. And we will find the values of k. So therefore, dy over dx is equal to 4 times of 4x minus k minus 4 times of 4x plus k. And that's all over 4x minus k squared. So we know that negative 8 over 27 of 4x minus k squared equals to 16x minus 4k minus 16x minus 4k. So negative 8 over 27, and if we expand the inside here, we have 16x squared minus 8kx plus k squared. And that is equal to negative 8k. Alright, so now we just need to simplify by multiplying through by negative 8 over 27. So negative 8. Alright, so we have negative 128 over 27x squared plus 64 over 27kx minus 8 over 27k squared, and that is equal to negative 8k. Now we know this is the x coordinate of 3, so we just need to plug in x equals to 3 into this equation. So negative 128 over 27 times 9 plus 64 over 27 times 3k minus 8 over 27k squared equals negative 8k. So negative 128 over 3 plus 64 over 9k plus 8k minus 28 over, not 28, minus 8 over 27k squared equals 0. So we just need to do some more simplifying. So plus 8. So therefore we have negative 8 over 27k squared plus 136 over 9k minus 128 over 3 is equal to 0. And we just need to go solve this quadratic. And we should get that k equals to 48 and k equals to 3. And checking back, k is, so checking that k equals to 3 is fine, yeah. Alright, so k equals to 48 and k equals to 3. And that's our final answer. This should just be a merit level question with an achieved level grade coming when, guess if we can get the correct derivative, that could be a achieved level grade. Question E. A lamp is suspended above the center round table of radius r. The height of the lamp above the table is adjustable. So h is changing, r is constant, and point P is on the edge of the table. And at the point P, the illumination I is directly proportional to the cosine of angle theta in the above diagram, and inversely proportional to the square of the distance, s, to the lamp. So I equals to k cos theta over s squared, where k is a constant. Prove that the edge of the table will have a maximum illumination when h equals to r over 3. So in this case, we want to have I explicitly in terms of h. So in this case, we see that cos theta. So in this case, we see cos theta is equal to h over s. And we know that r squared plus h squared equals to s squared. And therefore, s is equal to square root of r squared plus h squared. So making the substitution that cos theta equals to h over s, we say that I equals to k times of h over s times 1 over s squared, and that's equal to kh over s cubed. So s cubed is equal to r squared plus h squared to the power of 3 over 2. And we can plug that in terms of I, in terms of s cubed. So I equals to k h over r squared plus h squared over 3 over 2. And therefore I equals to k h times r squared plus h squared to the power of negative 3 over 2. So since r is constant, we don't need to worry about it. So we need to differentiate I with respect to h. So di over dh, so we can use the product rule. So that equals to k times of r squared plus h squared to the power of negative 3 over 2 minus 3 over 2 kh times r squared plus h squared to the power of negative 5 over 2 times the derivative of the inside function, which is 2h. Alright, so in this case, we know di over dh equals to 0. So therefore, we can divide both sides by r squared plus h squared to the power of negative 3 over 2 and divide by k. So k cancels through. So we have di over dh is equal to 1 minus 3 over 2 times of h. Times of h times of r squared plus h squared to the power of, so in this case we have negative 5 over 2 plus negative 3 over 2, since we're dividing through by r squared plus h squared to the power of negative 3 over 2. So we just have this is equal to negative 1 times 2h. So therefore we say that 3, what am I doing? Sorry. So 3 over 2h times 2h, that is equal to 3h squared. So 3h squared over r squared plus h squared equals to 1 Therefore, 3h squared equals to r squared plus h squared. And therefore 2h squared equals to r squared. And if we say that h squared equals to r squared over 2, so therefore h equals to plus or minus r over root 2. But obviously h is positive, so therefore h equals to r over root 2. And that is our final answer, which matches with the answer of h equals to r over root 2. And this will be an excellence level question. To get a merit grade should be a correct derivative. That should be around this point here. And if we can get the correct expression for I in terms of h only, so I in terms of h only, that should be an achieved grade. Alright, so thank you for watching this video. Hope you enjoyed, and I hope to see you all in the next one. Thank you.